Hello. So, welcome to this fireside chat on igniting India's AI potential. We all know generative AI has taken the world by storm, impacting every industry, every aspect of how we run things. So, the Generative AI Exchange Hackathon aims to use AI to unlock business and societal opportunities in India. With support from Google, Mighty Startup Hub, and Startup India, it brings together developers, enterprises, and ecosystem partners to empower participants with knowledge, tools, and mentorship. We want to thank People+AI for the valued partnership on this initiative. Hi, I'm Manish Gupta. I lead Google DeepMind in India. And with me, I have today Tanuj Bhojwani, who's a leader in AI for India. Tanuj heads the nonprofit People+AI. He's worked on digital public infrastructure with Nandan Nilekani since 2016, contributing to technical, legal, and policy aspects. Tanuj co authored The Art of Bitfulness with Nandan and serves on the Digital Public Goods Alliance board. Previously, he's worked on policy issues at iSpirit Foundation and has experience as a VC and entrepreneur. So, Tanuj, we know AI is transforming our lives in ways we have only started to comprehend. And of course, we are very happy to partner with you on this Gen AI Exchange Hackathon to help nurture the next generation of AI startups. So, welcome to this conversation, and thanks for joining us. So, my first question to you is: how has your experience at People+AI influenced your perspective on the potential of AI for India's growth and development? What do you see as the most promising areas for AI development in India, and which industries are most likely to benefit from AI advancements?
Yeah. First of all, thank you, Manish, and thank you, Google, for having this sort of hackathon. I sincerely, one, you asked a very broad question. I can go on for the whole hour on just this question, which, but before I do that, I want to point out that one of the learnings has been that we are bottlenecked by our imagination for what these technologies can do. We are learning, so even the idea of chain of thought reasoning, right? It's very unlike say the work that you and your team have done on things like Alpha Proteo or Alpha Fold, right? These are sort of more within grasp reach, right? Like the idea of expanding thought and expanding reasoning chains, and then using that to get the LLM repetitive calls, the idea of agents. I feel like this is such an exciting area right now that we are mostly bottlenecked by our imagination and the number of tinkerers, right? The number of people who are playing at the edges and doing something with it, which was the intent behind People+AI. I'll come to that in a moment. So I'm very grateful for the hackathon, and I'm anybody watching who's thinking about doing something. You are at the forefront of the future. So I'm very excited to have this conversation so that we can all come up with some ideas together. What areas are most promising in our work? So some very quick background for your listeners. People+AI, not-for-profit, funded by Nandan and Rohini Nilekani. A lot of the people here and sort of the mentors for this organization are from the DPI journey. So India Stack, Aadhaar, UPI, FASTag, DigiLocker, DigiYatra, all of those things. I've always had this public spirited view of technology. How do we create technology that helps everybody? And never before have we been so excited about the power of something since, say, the mobile, the handheld mobile device and Geo 4G maybe, which lowered the cost of the internet, getting to people. I think since those two epics about 2010, 11, and then 16 for 4G, prices crashing. I think this is the next big thing that we have seen in that inclusivity angle. Simply put, I know this is a project close to your heart also, Manish, like a Project Vani. Simply put, I think for the first time, barriers of education, barriers of language, barriers of literacy will not get in the way of people accessing software and information and knowledge that could meaningfully change their lives. To answer your question in short, which areas am I most excited about? I think the number one is health. I think health comes down to the difference between somebody who's healthy and not healthy. Yes, there is some genetical and some things outside of our control, but almost everything else comes down to habits, practices, knowledge, information, acting at the right time, something that these new class of technologies can really, really help with. And having said that, there's also very classical layers of AI sort of imaging, like on medical imaging devices, the data that comes out of it, whether it is screening for TB, whether it is, being a little more predictive about diseases, whether it is helping people understand their own blood reports and understand what they should do, right? And communicating all of that to them in a language that they are familiar with. I am most significantly excited about the potential in health because it is otherwise a problem where it's a lagging indicator, right? Like it's always the rich countries where once you have income, once you have stability, once you have social sort of status order, everything sorted, then they start caring about their health and healthcare and health outcomes, right? I think for the first time we can flip it around. And given that the country of India is having its demographic dividend, if you have a healthy young population on top of that, sort of we can accelerate the fruits of that dividend. So like number one for me is healthcare. And then the problems that we've put out there, I like to call this sort of ideas of um, really, like you said, empower people, right? So this is ideas of really empowering people to do sort of things that they could not do before. We have put out two problem statements ourselves in the Gen AI hackathon. One on consume wise, which is how do you get to know about the food that you're consuming and is it good for you, or if you're, any product that you're consuming, even skincare, etc., is it really sustainable? Is it really good for you? Simplifying that information. And the second is the city AI engine problem, uh, in which the city AI engine problem, in which we're trying to see if regular citizens can be empowered with creating truth and data sets about their own cities. So, like we're starting with something like the walkability index. So, are your cities walkable? Right? Do the footpaths exist? Where do not exist? Being able to visualize all that, and can the crowd come together and build this up? This is another example where we flip it. Software is usually made by big guys for managing their stuff, right? But can citizens come together, build software using Gen AI that helps them interact with their local sort of environments and fulfill their needs? I'll pause here because I don't want to take this too far, but I just thought I'd give you a little flavor. Is that sort of I'd also love
Yeah.
to hear what you think, Manish.
No, no, thanks, Tanuj, for sharing those thoughts. And again, I couldn't agree more with you. Health is something which is so important, and I think India really has an opportunity to leapfrog. Because I mean, I also think of the conventional healthcare system, right, as a sick care system, and if we can keep people healthier and take more proactive action, right, take action at an early stage, that is really a key to both better outcome for people, for patients, for people, and also it reduces costs. So and again, thanks for sharing these very exciting problem statements. So let me ask my next question. So in your opinion, so India has a lot of very diverse talent pool and rich cultural heritage. So how can we leverage this to drive AI innovation, which is both globally competitive and locally relevant?
That's a very interesting question. I think, while there are certain areas like software development where we are seeing the rapid advancement in the capability of these systems to fairly autonomously reason, plan, and complete tasks, I think for a lot of tasks where that human judgment or taking a call on certain kind of like moral ethical values, right, which the calculus of which is little more complex than can be described neatly in an equation, we will always have this human in the loop concept, right? We will always have somebody in there who is taking that decision or who is overseeing the outputs of an AI. And therefore, this comes back to the arguments of what a GCC or an ITIS did in India. We have that young talent who is able to grasp these concepts. We have a fairly vast educational system. It already reaches a lot of people. A lot of people get to college and get a education degree. I think I have seen startups now, such as Clarity Law and others, who are using specific professions in India to co-pilot with an AI to solve business problems around the globe. So that's one set of ideas I'm very, very excited by. That the it's in some sense it's an extension of, like I was saying, IT enabled services, BPO, GCCs, global capability centers, and now I think this human plus AI extension being serving the world is another idea. We're already seeing this happen in many areas. For even for something as simple as e-commerce, cross-border e-commerce, you have sellers say out of Germany, etc. Once their business starts growing, they need help. the help they need can be taken up completely remotely, and that remotely could be somebody in India with AI. So that's sort of one set of answers I see. The second thing that I see, sort of, where India is sort of its own sort of markets, right? Like when we say that India has this rich culture, etc., goes back to a point I was earlier making, which is that for the first time, um, we will have people who will be able to access information or internet services the way that you and I use Google search and use social media to get some relevant what our people are thinking, or get log on to like something like, or search for something or book a restaurant and do simple things that we can do. I think a vast majority of the Indian population, while they are able to log in online and maybe go to a YouTube, they're still not able to use these complex interactions, right? Especially when there is, say, payment involved or credit or anything that is a more complex transaction. I think that unlocking that in local language, um, uh, not not just translation, sort of rich interactions, especially when you take into account that in India, the official literacy stats are that 3 in 4 people can read or write. So that means at least 1 in 4 officially can't read or write. But if you actually take that in practice, what it means to say how many people can read a newspaper cover to cover and to fully assimilate it, I would say that number would be even lesser, right? It's not 3 in 4; it's probably closer to 1 in 2, right? Which means a vast population who've not experienced the magic of the internet as you and I have today. If somebody told me that they'll take away Google or I have to pay $20 a month to use the search engine, I would probably pay. But these people, for them, the jump is not going to be, from one search engine to say a Gemini powered, sort of conversational search. That's not the jump. For them, the jump is going to be nothing to a conversational powered search, right? And therefore, the value proposition for these users is even higher. And I think that has always been underestimated. Even when Geo 4G, the example I was giving earlier, was rolled out, the price of data crashed by about, I think, from 260 rupees to 9 rupees. And the number of users went up some 9 or 10x, right? But before that, very easily people would have made the argument, yeah, but what will somebody who's in a village do with the internet, right? I think in some of these cases, it's the other way around. Once something like a Project Vani or what is happening at AI for Bharat makes the language available, you will find use cases that were never thought of before that these people will want. Um, so I think those two opportunities, right? India for the world, with our talent and demographic potential, and also for India in these local languages. A hint of this, not a GenAI application, but I know of one company that we also called to our event, is a company called Stage, STAGE, Stage. Stage today is a very profitable OTT, one of the only few profitable ones. So the way that they talk about stages, it's the Netflix for Haryanvi. They have now expanded from Haryanvi to Rajasthan. But once again, it's a profitable OTT. They're doing well. They raised now money and now expanding into other regions. But just imagine this: just content tailored for a particular region. I want to make this note that just because it's for Haryanvi doesn't mean it is for low literacy people, right? Like a lot of the people there are people who speak English at work. But when they come back, when they're living in there somewhere away from their hometown, I'm from Hisar. I went studied in Delhi, then I got a job in Gurgaon, uh, in Haryana, but I'm still missing, the local content and what I used to watch as growing up as a kid. And now, even though I'm maybe working at a Google, right? But I mean, when I go back home, I want to watch Stage and not Netflix, right? Because I relate to that a lot more. So I think as India in general is having its sort of moment in the global stage where there's outside interest in our own culture, I think the newer generation is not sort of looking to globalize as much as they're looking to sort of reconnect with their roots. And I think that is a massive opportunity, right? So I think in all those areas, there's a lot of scope for things to be built.
No, absolutely, Anuj, Tanuj. I mean, yeah, I do think of ourselves, right, as the maybe the privileged ones, right, who understand
Yeah.
English and so on. And of course, I mean, we also love to. I mean, when we are consuming right, content for our entertainment, yeah, I want
Yeah,
to. Uh, I prefer Hindi songs, right, much more than
correct.
even though
Yeah,
I
exactly.
enjoy Western music, but yeah, nothing like Hindi songs. So
And
and
the recent Diljit Dosanjh concert, right, which people have gone crazy over, right? Like I really like that. I really like that we are reconnecting with our own stories and with our own sort of culture, music, etc. And I think maybe repackaging and retelling is needed, which once again, sort of these new large language models are a great tool to do that.
And on this, yeah, whole issue of democratizing access to information, right, and making the internet available in Indian languages. Of course, in addition to, I mean, that's definitely something that drives my team quite a lot. But I also want to call out some recent work by Mitesh Khapra, right, from AI for Bharat. It was an amazing milestone, right? They've released automatic speech recognition system for all 22 scheduled languages of India. So, which I think is an amazing milestone. So now let me kind of again moving back right to some of these problems, right? So some of these problems that are unique to India, you called out healthcare, then of course accessibility, education quality, agricultural productivity. So what role do you see AI in addressing some of these challenges that we face in India?
Excellent question. See, I think most of the problems, in these areas stem from a few key things that are like repeated problems in these places. I mean, one is incentive misalignment, right? Like, and often because of the size of India, you need middlemen, right? You can't have one hospital which serves the whole country. Like in Rwanda, for example, I remember that in 2014 I used to work on drones, and Rwanda had started air delivery, drone wire delivery of blood to hospitals because it was cheaper to build a drone base which covers two drone bases which cover the whole country, because it's a country of like 5-7 million people, than it was to build refrigeration and electricity and whatever in these countries, right? So they leapfrog even before India could, because India, the problem becomes we are very large, so we often have to rely on multiple sort of intermediaries, right? And then the incentive alignment amongst them becomes a huge problem, right? Like, why would this person be honest? And a lot of the systems, even Aadhaar, the help of DBT, direct benefit transfer, why Aadhaar helped in reducing corruption was because the money didn't go to the middleman. The money went directly then to the person at the end, right? I think now with agents, although this may mean different thing, not the AI agents that everybody's talking about, but agents on the ground who used to go give a service may had misincentives or different incentives than what the people had. But with a AI agent, right, you can then sort of create systems that have more rigid incentives and that can be monitored, which are more aligned with what people want. So I think that is one sort of problem that cuts across in, say, agriculture, where the only people giving agricultural information was the people who are selling you agricultural inputs. So the guy who sells you seeds is telling you which seeds to plant, when, how much fertilizer to apply, and then he's telling you which fertilizer is the same. The fertilizer is the one that he has in stock and makes the most margin, right? So separating the information and access to that information from the channels of sales and the channels of getting it, I think, is one general problem that cuts across many of this, right? In a similar vein, access to expertise, right? So in India, we talk about the ratio of teachers to students, doctors to students, but if you think about, if poverty is one of our biggest problems, you think about financial advisors, the number of financial advisors to the number of people, that is even more abysmal. We have only some 1,200 registered financial advisors for 1.2 billion people. Now, especially now with all this India Stack work, where anybody can open a demat account, and we're seeing a record number of like investment in the stock market, etc. You can start doing a mutual fund at 100 rupees, 500 rupees also. But who's giving the right advice on where to invest, what to invest? Once again, an AI agent can do that. So you can remove the bottlenecks on access to expertise. You may not want to replace a doctor, but say once you visit a doctor, right? What happens after the visit? Oh, should I take this medicine before or after? I'm still coughing after 7 days, this normal. These sort of little follow-ups, which are still safer to do, can be done by AI agents, then freeing up the doctors to see more patients, right? So that's the third kind of problem that we can address. Productivity boost, where we can make somebody or some individual human agent a lot more productive than we would otherwise. We are seeing an example of this 10-bed ICU. If you've not seen it already, Shrikant Nadamuni's pet project, which is doing really well, where they've created this sort of ICU in a box, right? So any state wants an ICU, they quickly, here is everything you need to set up an ICU. But then the problem they found was in the training. Where do you get nurses and doctors who are trained for ICUs if they've never been in one? And they are now using Gen AI to sort of help the nurses find the training, find the appropriate procedure, and get better at these things with this. Um, and so for this cuts across, like I can give you specific examples of this, but I want to give the category of problems to help people who are working on hackathons to think about how they can apply it to a domain they know. Um, Outside of this, I'm also very, very excited about a particular, it's not very, it's a simple technology. We just plug in an ASR, an LLM, and a TTS together, but we call it Jan Ki Baat, uh, which is the idea of listening at scale. One of the other problems that happens in a country of India's size is that you can never really know what's happening on the ground, right? And once again, the people who get you that information from the ground have a set of incentives to tell you what is different, right? So, for example, one of the most hotly debated numbers would be of the Swachh Bharat mission, right? We are claiming that we are, at least in certain areas, open defecation free, right? Or the number of toilets built are so much. And then some people may not still have access. Or, in fact, there's a problem that we are working on Jan Ki Baat, which is for the Jal mission for one of the governments, state governments, where the state government wants to just find out how many people have a tap, how many people are getting water in that tap, and of that, how many people are complaining the water is muddy or has a bad taste or a bad odor, versus how many people are saying it's drinking. Just finding this out would otherwise take them an army of surveyors. For months, they would have to first do this. So before you even do something to give somebody water, you would spend 6 months and like not thousands, but at least tens of crores in finding out where there is water, where there isn't water. And in 6 months, by the time you finish that data, that report, it's already out of date. So what you can do with GenAI is you can call up people, and like you can call up all of these people simultaneously. So in a day, you can call everybody and ask them this question: do you have water? Do you have a tap? Does it get water? Is it muddy? And or is it smell? And have you drank it? And is it safe, like, for you? And we can collate this report again with GenAI and tell you again what is happening. So we are doing this with Junkie Bar. So I think that even if you're not solving the core problem of, say, agriculture or education or healthcare with generative AI, by getting the right information in the right places and helping in other operational issues of the solution, like you may not have a generative AI that replaces a doctor, but that replaces the nurse, the ward boy, the hospital administration, all of that. If it can replace, it would be incredibly useful. I'll stop here again. I
Oh,
have too many ideas,
I I
but
love this idea, not just man ki baat, jan ki baat, and
yeah,
I can imagine, right? This is not only going to be far more cost effective and scale. I'm sure the quality the of information that you get is much better because we know otherwise, right? We end up spending so much money on collection of data, and often there are vested interests and so on, right? So the quality of information that you get is much poorer. So no,
yeah.
excellent concept. So now and again, I mean, there's absolutely no doubt. Fully agree with you. There are just so many opportunities for us to have impact. So let's turn our attention to some of these challenges. So first, how do you envision the future of AI governance in India, and in particular, balancing innovation with ethical considerations and regulatory frameworks?
So it's a very sort of interesting question. I think it's very hard to do a broad horizontal regulation on AI, and I think it's also harmful because our lack of knowledge of complete set of use cases, we might end up shutting down some parts that we shouldn't. So I am first of all of the belief that we should go back and identify specific harms and start protecting against those. Me and my team, we are currently working mostly on scams and scam calls. Like that's our biggest concern that we see. Once you have these deep fakes and whatever, just the modus operandi of scams will explode, and the number of people doing this will explode. Or even if not number of people, but what one person can do, right? Productivity of an individual scammer will explode, which is still as dangerous. Right? It's as dangerous as many more people doing it. So first of all, doing legislation or protections piecemeal for that particular scope, I think will be more effective. Uh, I, I give this example often that the Indian government, we had the IT rules, which were, in general in the 2000s, the internet boom, etc., and it came. But after that, we had a Digital India mission and programs of Digital India before we had a Digital India Act, or like a Data Protection Act. Right? We were still 2024. So Digital India mission was 2016, and like UPI and a bunch of other things came out of that. And but the digital DPDP, the data protection bill, is 2024, and it's still not operationalized fully, and we're still not fully clear on the details. Regulation tends to lag, and this is not necessarily a bad thing, right? We should, for very short-term things that are going out of hand, use sectoral regulators very carefully, like try for spam calls, etc. RBI and NPCI helping us on financial fraud in particular ways. But broad AI regulations, I'm a little more skeptical. When it comes to ethics, I think that's where companies and others should definitely sort of start taking on normative behavior, saying, look, we are doing this, right? We are going to label images as generated by AI. We are going to put signatures and voices that are generated by AI, etc. And those kind of concerns where we're preempting what can go wrong and we opt in to some norms are important. And I think here, unfortunately, there's only a few handful of companies who have to get together. The US, we saw this with the executive order by Biden. Many of them opted into safety testing. But I think the list of concerns there are frankly a little Western centric, right? Like safety, X risk, and those which are conversations there. I think in India, we have to worry a lot more about, what, like you and I know exactly what this technology does, or the people in this hackathon know, but like, does your average farmer or a brick factory worker, right, in somewhere in Bihar, know what this technology is, or know that if they get a call from somebody who sounds a lot like Amitabh Bachchan, that they should not trust it, right? These are things that I think we haven't really thought of in terms of ethics, etc. But we also have to get these concerns to the same set of model builders. So again, it's a conversation. I think it started already, much sooner than with other technologies like social media, but there's still a long way to go.
No, thanks for bringing those up. And certainly on things like synthetic content, I know, I mean, Google has already, with the Synth ID technology, which was initially developed for images, watermarking images, but now it's been applied for text, for videos, and so on. So we are certainly committed to doing that. And of course, I mean, we also, and thanks for calling out that a lot of this so far work in the area of responsible AI biases and so on has been done more in the Western context, and there's a need to do more. So again, my team has been releasing some of these benchmarks, which take the more of the non-Western lens over some of these dimensions of bias that we see language models carry, and we are beginning to release some of these data sets. But of course, there's a need to do much more. So I know, Tanuj, you are very passionate, and you talked about again how do we develop AI, right, in an inclusive manner, right, to bring the benefits to everyone. So what strategies do you believe are crucial to bridging the digital divide in India and ensuring that this AI advancement, right, benefits all segments of society? So what will be your message, right, to some of our entrepreneur friends?
I think this early in this day, right? It's just that there's a lot of, we live in an age where we have a lot of ways in which we can admire or have FOMO for people who are doing better than us. There aren't a lot of ways in which we get to peek into the lives of the people who are not doing as well as us, right? So even an Indian entrepreneur knows what Sam Altman and Elon Musk are saying, what advice is Naval Ravikant doing, or coming up with the ideas of charter cities and a network nation by Balaji S, right, in the crypto land, what they're doing. But like how many of you have maybe asked sort of what the people who work around you, and even the people who are working in service jobs in Bangalore are, I would say, the real middle class of India, right? So like the person who comes cooks at my house, so makes it at about 45,000 rupees a month, which from all the houses combined, which is honestly puts him once again in the top 10-15% of earners in India, right? But what are the average problems? And you'll be surprised at how much that has been solved for you is still a problem for them, right? One of the reasons, one of the things we did in India started Bharat bill payment system, and the insight was that a lot of people who can't use digital payments, etc., would have to to go pay a property tax, they would have to go to the regional head office to go pay the property tax, which means a whole day at minimum of wages lost and transportation costs to go pay a bill that they very easily could just take, from you digitally or any other way. So when you actually go look at the lives of people, like I was saying earlier, who haven't been touched by the internet, you will find a lot of meaningful problems to be solved. There are also problems in industries where technology and AI is not top of mind every day, like manufacturing, where I think there is a lot of potential, not just robotics, but sometimes even simple things in the process and the planning stage for a lot of these manufacturers, bringing in operational efficiencies once again there. These are going to require you to be able to meet these people who have these problems. So one thing I would say is go with your phones and your laptops and Claude and ChatGPT and go impress these people. Go show them what this is, and then give them something to play with and see what they ask, see what they immediately come up with, and say, can this do this? Can it have that? There's a very interesting company, Apps for Bharat, I think they were called, or I may be getting the name wrong. But what they did was they put out a Facebook ad or Instagram ad saying, if you want any app made, click here. अगर आपको अपने like in local language किसी भी चीज के लिए को आपको ऐप चाहिए तो आप यहाँ आइए. So people clicked the ad and started telling them मुझे ये ऐप चाहिए, मेरी community हम इसका group है, we want this, we want that, and they started building it, and it was like I
Wow.
thought it was a great hack, right? Like just ask the people what they want and build it, right?
Oh, fascinating. I mean,
Yeah,
talk about market research, right? I mean,
yeah, exactly. Yeah.
yeah. So no. So I'd like to also invite our people who have joined the chat to again ask if they have any questions. So let me ask the organizers. Are there any questions that we have received from the audience? Okay, so I see a few coming up. So here's one question from the audience. What sectors in India are best positioned to benefit from AI in the coming years? So which sectors do you think are ripe for disruption?
Okay, and this is it's tough to
Because you could
like
say
see.
which sector is not going to be disrupted,
Not,
right?
yeah, yeah. See, I think I'll try to be useful, right? One is, like I said, increasing access, right? Like, which means that you look at what is hard or expensive for people to get, and your typical quality healthcare, quality education, and there's a bunch of these which are also closely linked to our developmental outcomes, right? Then there are sectors that are going to be disrupted, which is things that are happening today that are unlikely to happen the same day tomorrow, right? And here you have a lot of like BPO call centers, right? Like where automation is trickling in, we're seeing it already. That's also, I think, where disruption can happen very easily. A lot of these information jobs, or others like matching, where there's an intensive human set people matching ideas or matching people, like like headhunting, etc. Right? Like, which a lot of this I think can get automated, and with the better use of information, the better crawling and storing and managing of information, I'm much more likelier to tell you which candidates are likelier to fit for you uh, based on crawling that data than to have to like do headhunting, etc. So those are also areas where I think disruption is coming. Um, but I am actually very interested in sort of the second order changes, which is that I think um, what will happen is that a lot of firms will not need as many people to do the things they do. And this is going to be especially true in technology. You're going to be able to do a lot more in a software or a SaaS firm with a smaller team than you were doing earlier with larger and larger teams. Now, the second order effect of that is that a lot of the tools and the softwares that people use for large firms for managing, which often is a big sort of SaaS revenue, stuff. So again, Salesforce is one classic example. CRM, because sort of large sales forces selling to a lot of people need coordination mechanisms, need some software that has been like straight jacketed and done, but at the same time has extensibility and functionality. But you need that when your sales force is 500 or 5,000 yourself. But if your sales force is only 50, right? What happens then? Do you really need a sales force, or do you need a more custom software? And at that point, you have to ask the question: do you need SaaS, or do you need custom, a Gen AI development firm that works for you? Right? Might be a better idea than going in SaaS. You can keep updating and doing this, right? So I think the second order effects of disruption are going to be these entire categories that go away. So BPO and all of this goes away. SaaS doesn't exactly go away, but becomes a very different beast because you're no longer selling 100 plus licenses on the enterprise grade. Enterprise licenses might come down to just 20, 30, 50, right? Because what was traditionally a SaaS firm can happen with only 10 people. So I think those are places where if you have something, it'll be interesting.
No, no, absolutely. And in fact, to your point about how now you could do much more, right, with the help of AI, right? The same software developers could do so much more. I can also imagine, right, problems that previously, right, it would not have been economically maybe viable to come up with the
Yeah.
solution, right? And now, because of the higher productivity, right, these things becoming viable. So
Yeah.
I'm sure there are so many new opportunities, right, that will also open up. So the next question I see from the audience is, how can AI actually impact Indian masses, including underprivileged, marginalized sections of society, if the cost of underlying infrastructure is high? So what business model can be used to create low-cost apps?
So this is a great question. Whoever asked this, props to you for thinking about this. Because in India, there's this famous William Gibson quote: "The future is already here; it is not evenly distributed." Right?
Right.
And India is the classic example of that. Whenever it comes to any technology, we have found a way to distribute it at a cheaper cost. Usually, this is some form of timeplexing, as it's called, or multiplexing, or batching, or something like that. Which what does this mean? Like PCO, the public call office, was a very Indian thing, right? Where people would go, like some entrepreneur, local village entrepreneur would buy one phone line and charge everybody 1 rupee per minute to use it, right? So you didn't have a phone in every house like the US and Europe started having landlines, but we had this. And then when the mobile came in, the economic value of the mobile was so much, right, that everybody adopted mobile, right? First the small mobile, and then when Geo dropped the rates of 4G, everybody adopted internet, right? So these are some ways in which you can do it. You can create infrastructure locally, right, that can be shared. So we ourselves are thinking about this, where we are thinking about these machines, AI machines that can have local community users. So one of the things we are doing is CCTV sort of Gen AI applications. A lot of shops, we released a report called the People's Voice. You'll find it on our website. We were talking about the lives of MSME. How can they use Gen AI, right? So we have a whole report on how MSMEs can use Gen AI. And the MSMEs, one thing we realize is every MSME, every small shop, 500 square foot or less, will have a CCTV because that person's entire life and their entire capital is stuck in that shop. So fire, theft, mismanagement, sudden customer influx. I'm not in the shop, but 4 customers have come in. I will drop whatever I'm doing, come in, try to get their business, right? Building Gen AI applications for them on top of their CCTV stream will require compute. Now, are these people likely to open even a Google Cloud account or what? Not really. So we think that installing infrastructure locally and then sharing it locally, like a PCO for AI, might be an option. So we're exploring certain ideas there. So I do think that uh, don't get carried away with sort of large model, large usage. We are seeing like even with the Gemini Nano sort of models, there is a lot of use cases you can derive with just a very small um, model, right? And it's just that how do you get that to somebody and prove value? That is the real ask here.
No, thanks. So I see another very interesting question. So, what is your view of what types of applications of Gen AI are overused, and what are some of the underrated ones?
Okay, I'll tell you one thing that I think the sort of the name artificial intelligence and chatbots and like even chat GPT has over indexed us on a certain text and a chatbot or like a intelligent being on the other end and human on this end kind of interaction always. The other paradigm is co-pilot, right? Like I am doing something, something will come and help, etc. But I think there are certain other sort of like roles or framings that we've not we've not really explored. So to me, the overuse is the chatbot, right? Anything that is trying to say it's a chatbot is already, I think, done because I barely like chatting to people. They come texting. It's like just talking to an AI is going to be, I don't know how much better or worse. I want stuff done. Right? The best thing, or if you go to a really luxury hotel, right? Like one of the things that they do is not like they're bed is insanely more expensive, or the water in the shower is like, something. It's just that the thoughtfulness of little details like that is just automatic, right? Like you come in and somebody's ready to give you a drink so that because they know you're exhausted, right? They keep your luggage in an area they know that you don't want to carry it all the way, then carry it to three places. It's just little things that AI manages. So this is where the concept that we call AI in the flow, right? It's if as you're doing things, if AI can be um, predictive in the right way and suggest to you what you can do here, I think that is the best kind of use cases for AI. The biggest example for this I know is GitHub Copilot when they did what's called Ghostwriter. So GitHub Copilot said that since GPT-2 already and even at GPT-3, they knew that code completion with these models was going to be a use case, but they said that they did not unlock that exponential curve of daily active users until they introduced a feature called Ghostwriter. Ghostwriter is very much like how in Gmail autocomplete comes in gray in the background, right? As you're typing, it comes in the background. They did that for code. So like press tab to complete the code, which they're showing you. So as you start typing define function or doing anything, it starts showing you the rest. And they said that just not having to get people to think about taking this problem and going to another app and doing it there, but like doing it in the flow of as you're writing the code, that was the key difference, right? And they said that once that happened, they had exponential curve growth to 100 million users. Similarly, I feel like we need to like the unexplored is try to figure out what people are already trying to do, and it's tough. It's heavy, cognitively heavy, etc. And can you get in the flow and get AI silently there? I think those are magical experiences that people will just naturally adopt. Anything that requires them to have a mental model or chatbot, copilot, I think is going to be a little harder.
Okay, so my last question. Yeah, we have to wrap up soon. So, why is India's AI market far smaller than the US, China, in particular, those two countries? And what can students do?
Yeah. So I think the reality is that a lot of, once I said, the Western conception of AI is labor replacement, right? Like they're still looking at this as how can we not have as many people for say customer support, etc., and replace it with AI because of the cost centers, right? And I think there, the grim reality of the situation is that more developed economies, labor costs high. So automation of labor is always a use case because it saves money, has reliability, gets rid of a lot of headaches. To be sincere, right? It's not just the cost. If something is automated and machine works 24/7, right? I mean, bar for bugs, etc. In India, therefore, labor replacement solutions, if you go look for which companies are doing this or doing that, here the calculus is so much different, right? You can just hire somebody to do that job and they will also supervise, make like see the mistakes, double check it. Whereas if at a 90% or 95% solution, the cost calculation in the US or China may be different from in India because they're like, who will look at the 5%? I have to hire somebody anyway. Might as well get them to do all of it. So I think labor substitution does not work. But access, magical experiences. There's a lot of places where stigma or other things may get in the way, right? So one of the most popular use cases that we're seeing in India for us is this mental health kind of chatbots, right? I wouldn't say once again replacing the therapist, but sort of what I am calling uh, like first aid, mental first aid, right? Which is that at least if I am at this point, there's an exam and I'm feeling anxious, right? Or I'm feeling stressed, and I'm ashamed to talk about this to anybody, to my peers. Like I feel my peers are all smarter than me; they're not having this problem. So I need to go talk to somebody. But there's so much stigma in talking to another human, even if they're a licensed mental health practitioner. But maybe I might prefer to talk to a chatbot because I know that I'm talking to a machine in some sense, but it's helpful. So we're seeing some use cases of that, and therefore the context of the country matters a lot. India, for example, is not the greatest car country, but we are the world's largest two-wheeler market, right? So when it comes to like EVs of two-wheelers, we are leading the world, right? But when it comes to electric vehicles per se, or even vehicles, we are not doing so well. So, the reality of an economy is the reality of an economy. I don't think we can fight against it. What can students do? I think, honestly, again, Google products also, YouTube search, a lot of these places, India is the number one user, I think. Like voice search, I believe India is the number one user of voice search. So our population does make certain products attractive. You can think about what those mass products are. You can build those, and the use of AI increases. But it's just a question of which use case. I don't think the same use cases will have the same size of market, but in some other use cases, we might be even bigger market than what the US and China offers.
So Tanuj, I know we could go on and on. Thanks
Yes.
so much for your again fascinating insights, and I hope, and I'd like to also thank our audience for joining this discussion. I hope you found it as interesting as I did. And so, with that, let me also kind of just remind people about an upcoming technical workshop on deploying and hosting in the cloud and tuning an RLHF. So if you haven't registered yet for the hackathon, please find the registration link in the chat box. So again, I'd like to thank first and foremost Tanuj for sharing all of your insights, and then all of you for joining. So thanks, and again, have a nice day.
Thank you, Manish. Thank you so much for having me here. And just my message to the teams, please submit something, submit anything. You never know sort of, what is a good idea for somebody else. I'm really excited to see what comes out of this hackathon.
Thank you.
Thank you. Thank you.
Okay. Welcome everyone to the Gen AI Exchange Hackathon by Google, supported by Mighty Startup Hub and Startup India, in partnership with startups, enterprises, and VCs. Thank you for joining us today. Hope I'm clearly audible. If you haven't registered for the hackathon yet, please find the registration link in the chat box. I hope yesterday's session on RAG architecture and building enterprise apps was really valuable. Hope so. Have you ever wondered what does it take to design and deploy a Gen AI application on cloud? Is writing good prompts enough? What models do I choose? Then this is the right webinar for you. What we'll do today is deep dive into deploying and hosting apps in the cloud, tuning, and RLHF. I'm Gaurav, customer engineer, infrastructure modernization specialist at Google Cloud, and I'll be hosting this workshop for you. Feel free to ask questions throughout the session, and I'll do my best to address them at the end of the session. So in the next hour, we'll look at the end-to-end process and the tools available in Google Cloud to develop and deploy the Gen AI applications. I'll also share some resources or starter projects that you can leverage to fast track your development efforts. Finally, I'll also present the various tuning options on Google Cloud. So let's get started. Okay, so first, once you have identified a use case to solve using Gen AI, the very first step is to choose the most appropriate model. Now, when selecting a model, keep these factors in mind. I'll walk you through the different model options that are available to you in the later slides. But for now, just keep these factors in mind that you should think through when you select a model. First is modality, which essentially refers to the data types the model is trained on. Example, text, images, videos, audio files, unstructured documents. The use case that you think through should align with the model's modality. For instance, text to image generation requires a model that is trained on both text and image data. So you need to select a model which basically supports, which is basically trained on both text and image data if you have a text to image generation kind of use case. We also have a lot of multimodal models now that support various input combinations. So you can have an input which is a combination of text plus image, text plus video, text plus audio, and so on and so forth. So keep that in mind as well. Next is the model size, which is typically measured by the parameter count, and it also impacts the performance of the model. Now, larger models can learn complex patterns and potentially yield higher quality results, but they may also have higher latency and costs. Remember that for large language models, bigger isn't always the better, since, like I mentioned, larger models can have higher latency and costs as well. That is why the model cost is extremely important, because it is also linked to its capabilities. And like I said, it is often reflected in its parameter count as well. Also keep in mind that the billing methods can vary, right? So say, for example, a model can be built on the number of input characters, the number of output characters. It might also be built on the number of input and output tokens that the model is able to take as an input and generate as an output. It might also be built as the number of images that it is generating, the number of or the amount of audio seconds or the video seconds that it is processing. So keep the factors that impact the cost of a model in mind as well. Next is the features. Not all models support features like tuning and distillation, which we'll talk later, but consider these aspects if they are important for your use case. The next step is essentially designing effective prompts for your specific use case. Now, it's normal if you don't get it perfect right away. You should keep refining the prompts until you achieve the desired response. As per my experience, what we have seen is providing examples or using few short prompting can be very helpful in this process. Again, we had an earlier session which was a prompt engineering 101. So everyone who has attended that, hope that was really helpful for you to basically understand what are some of the best practices that you can follow to essentially write effective prompts against the models. Now, depending on your use case, you may also need to customize the model. So we will discuss this in more detail in the upcoming slides. The next factor to consider essentially is the model evaluation, right? So this is also an extremely important part of your application development. What essentially model evaluation means is you essentially are assessing how your prompts and the customizations impact the model's performance. Each evaluation method that you pick and choose has its own strengths and methods, or strengths and weaknesses. On Vertex AI, we offer automatic side-by-side evaluation, which essentially allows you to compare the output of two models against the ground truth that you have established. Now, for any evaluation method, keep in mind that you would always need an evaluation dataset as well, which essentially includes the prompts that you want to pass the model to generate the output, and the ground truth or the ideal response pairs that you can create, right? So essentially this evaluation data set is what you can pass the prompts to a model, to a set of models. You get the output, you compare those outputs against the ground truth that you have documented or created. Next, deploying a model involves associating an endpoint and the physical compute resources with your model for serving online low latency predictions. Now, keep in mind that not all models require a deployment, right? For instance, the Gemini models or the Google's foundation models that we have available in Vertex AI, they already have an endpoint specific to your Google Cloud project, right? And are immediately available. So all you need to do is you just have to use maybe a client SDK or a library or an API call to essentially access those endpoints, pass a prompt, get the response from those models, and basically configure a few settings, right? So it is that easy. However, if you tune any of these models, you have to deploy them onto an endpoint. So keep that in mind as well. Finally, all of these components that we see in the screen will be integrated into your application code using various client libraries or SDKs. Right? So let's recap the key components of your application architecture. So if you look at it, to ensure optimal performance, you need to determine the ideal hosting infrastructure for both your application as well as for your model. Additionally, we will also explore some of the grounding solutions or techniques that are available to basically enhance the accuracy and contextual relevance of your model's responses. So let's deep dive into these factors that will essentially guide us in finalizing the most effective architecture for your application. So Google Cloud offers a variety of compute options to suit your applications, right? So essentially, again, to determine what would be the best fit in terms of hosting your application, consider whether you prefer managed serverless infrastructure. If you do that, Cloud Run is an excellent choice, enabling deployment from source code, Docker files, or existing container images without the burden of managing the underlying infrastructure. Now, Cloud Run also provides you with hyper elastic scaling, right, including scale to zero, which essentially means that you now have predictable costs, optimal performance, and faster time to market, right? On the other hand, if your team possesses the skills to manage the cloud infrastructure, but you still seek a service for deploying and running containers at scale, then GKE or Cloud or Google Kubernetes Engine is the ideal choice for you, right? Because this is the first serverless Kubernetes offering. GKE provides unparalleled simplicity and automation, empowering you to focus on your business goals rather than having to manage the underlying infrastructure. It also has built-in automated workload scaling and battle-tested configurations, which ensures that your applications meet the critical scale demands for your end users. And finally, for applications, Compute Engine remains a viable option, offering features like auto scaling through managed instance groups. On Google Cloud, you also have custom machine types that you can create, which allows you to be able to, optimize the costs or optimize the consumption that you have to pay for when using Compute Engine VMs. Now let's look at, or let's explore the model hosting infrastructure options that are available to us. Google offers primarily two ways to access their foundation models, right? So like I mentioned, Google has a lot of pre-trained foundation models that are pre-deployed or deployed on an endpoint for you. The Gemini Developer API is the easiest way to get started, but it's important to note that it lacks enterprise features like scaling, security, data privacy, and observability. On the other hand, if you have Gemini on Vertex AI, it is a fully managed enterprise generative AI offering that prioritizes data security and privacy. By using Google Cloud's hosted Gemini endpoints, you can focus on your core business logic without worrying about or maintaining the model infrastructure, right? Additionally, within Vertex AI, we also have something called as Vertex AI Model Garden, which provides you access to many popular third-party and open models, including Meta's Llama models or Anthropic's Claude models. You can also browse over 4,000 models from Hugging Face within Vertex AI Model Garden and deploy any of them, including the Meta and Anthropic models that I spoke of, to Vertex AI with a single click, right? So this is the kind of efficiency that you get. With a single click, you can deploy any of these models into Vertex AI. You get the endpoint and you can integrate those endpoints as part of your applications. If you want to fine tune any of these models, which we will discuss later, we also provide you starter notebooks that you can leverage to be able to fine tune these third party or open models. Vertex AI also offers end-to-end MLOps capabilities for fine-tuning and deploying models, right? So if you want to create a production-grade pipeline for fine-tuning and deploying and monitoring your models within Vertex AI, we also offer those MLOps capabilities. Finally, for if the requirement is to essentially create custom large language models, Google Cloud allows you to train your models using GPUs and TPUs on the global infrastructure that we have. You can then deploy these train models onto Vertex AI managed platform, Kubernetes, or GKE, depending on factors like specialized kernel requirements, legacy OS compatibility, or specific licensing needs that you might have. Now that we have covered application and model hosting options, let's focus on selecting the right model for your needs. As I mentioned earlier, this choice depends heavily on the modality of your use case, right? So to assist you in this process, I have provided a decision tree that you see in the screen right now. So essentially what you should do is the first question that you should ask is, how many input modalities do I have for my use case, right? Whether it's a unimodal, which is essentially text as an input, or if it is multimodal, wherein it can be a combination of text plus image, video, audio, PDF files, and so on and so forth, right? The next question that you should ask is, how long is your input in terms of tokens, right? So if you have a very long form content like you see here, you essentially should use either Gemini 1.5 Pro or Gemini 1.5 Flash models that we have, because these two models, they offer you the largest input context window. Gemini 1.5 Pro provides you a context window of 2 million tokens, up to 2 million tokens. And Gemini 1.5 Flash provides you a context window of up to 1 million tokens, right? So keep that in mind. On the other hand, if you have a multimodal kind of a use case, but the input that you are going to provide to the model is going to be either very few text or very small text or a medium long text, you can even go for Gemini Pro Vision 1.0, which is again a Vertex AI model that is available. If you have a use case wherein you have image as an input and you want to ask questions on top of the image, you want to analyze the image and answer certain attributes or extract certain attributes from the image, you can even use Imagine Visual Q&A model that we have. On the other side, if you have a unimodal kind of a requirement and a short or a medium kind of a input token window, you should then think of as to what the output modalities are going to be, right? So if it is image as the output, so essentially for any image generation or editing features or capabilities that you need, you can use the Imagine models on Vertex AI, which can essentially create and modify high quality images within seconds. Their editing features, including object removal, insertion, outpainting, and product editing, they support various use cases in retail, marketing, creative, advertising, and more. If you have a use case wherein the output would be code that you want to generate with code as an input or text as an input, we have a lot of these code generation models as part of our Cody family on Vertex AI. Now, the reason for recommending this model is because this model is fine-tuned to suggest code completions based on the context of your existing code, and it supports the English language only as an output. Similarly, if you have a free-flowing text or a free-form text or a natural language text as an output, you can use Gemini Pro 1.0, you can use Gemini 1.5 Pro, 1.5 Flash as well. Plus, you can also use any of these text Bison or text unicorn models that we have, right? So essentially, the idea is keep this decision tree handy, keep this decision tree in mind, because a lot of this depends on the kind of input modality that you want to have. Plus, like we discussed in the earlier screen, it also depends on the cost, right? So each of these models that we see here would come with its own pricing, right? So keep the pricing in mind as well, and the modality or the output that you want to generate in mind when you want to decide what kind of model you should use for your applications. Now, what if your application needs to call different models based on the use case, right? For example, you're developing a creative writing assistant which serves multiple use cases. It can generate a creative content based on an input text from the user. It can also generate an image that goes with the creative content that was generated by your application. You might also want to use the creative writing assistant to proofread an existing write-up. You essentially need to match your use case to the models that are available, right? So you would have seen in the last screen, we have a lot of different models that are available. A very simple way to implement this is to have different pipelines created like you see in the screen here, right? So for different use cases as you see here. Now, you can take this approach a step further and introduce what we call as a dynamic model routing. So the idea is that based on the input prompt, you trigger a Cloud Run function which uses the routing logic that you have defined within the Cloud function itself or the Cloud Run function itself to identify the model suitable for the input prompt, call the model or endpoint from maybe within the same Cloud Run function or a different Cloud Run function, and return the response to your application, right? So this is again this is a different approach wherein you can introduce dynamic model routing as part of your application. You can further extend this dynamic model routing to be more of a data driven model routing, wherein you essentially train a classifier model using Vertex AI to predict the model that should be called for the input prompt, right? Obviously, for you to be able to train that classifier model, you would need a data set, training data set, and a test data set to be prepared, which would essentially be that if these are the sample prompt inputs that you have, then these are the models that you should recommend as an output, right? So you train a classifier model on Vertex AI, you deploy it to an endpoint, and then you essentially use that classifier model, you call that model endpoint as part of your application to be able to predict what the model should be that should be called for depending on the input prompt, right? So all of these techniques that I showed you in the previous few screens, they allow you to extend your application to be able to accept different forms or modalities of inputs, as well as to cater to various use cases from a single interface, right? So that is the benefit that you would get with all of these different approaches that we have. Now, grounding in generative AI is another key feature, which is essentially used to ensure accuracy and reliability, right? So now I know that we had a session yesterday on RAG-based approach or vertex search as well, but I wanted to cover a few key fundamentals of what goes behind, building out a RAG search yourself, right? Because today RAG is a very popular way to implement grounding with Gen AI applications, right? So honestly, if you look at this screen, it's too trafficy, but honestly, there are a lot of different ways to do it. But here's a pretty standard pattern that I saw that I show you here in this screen, right? First of all, you have to decide what data to collect, whether it's public data, private data, whether it is unstructured data or structured data like a database or a spreadsheet. Next, you have to be able to extract information from the documents. Sometimes that's very easy, like for a text document or an HTML, but sometimes it's really hard, right? So consider parsing PDFs with wonky page breaks and embedded data across many different layouts. There might even be images that are embedded within the PDFs, and these are actual images with graphics and relevant information within those images. So due to this, chunking is a process which is very important part of this processing, because the meaning of a sentence is often related to the previous sentence or the section heading or page title or any of these combinations. So first you essentially extract data from these documents that you have. You then chunk that data that you have extracted, and then you vectorize it. What we mean by vectorizing it essentially is to encode the semantic meaning into vectors that you create as would be interpreted by a large language model. And then these vectors are then written down for subsequent lookup, right? So you would essentially say, store these vector embeddings that you create for the chunks of data that you have extracted into a storage, right? Into a database or a vector database, right? And then at runtime, when a user enters a query, you probably should do a spell check or create a few variations of the wordings, basically just to ensure that you're able to get a better response from your vector database or search that you've created. And then essentially you do a vector search for, say, again, there are various algorithms that you can use for vector search, right? So we have things like approximate nearest neighbors or inverted file search across features to essentially identify or get the search results from the vector database. And you're not done yet, right? Because once you retrieve the search results, you have to rank those search results for relevancy to the queries that you have, right? Finally, after you do all of this, you essentially pass the search results as part of the context to a large language model, and then try to get well-grounded summaries from the large language model. And all of this has to be hosted somewhere secure, performant, and stable, right? So honestly, as you would see, it's a lot, right? Or you could use a managed service which Google Cloud provides, such as Vector AI Search for your RAG applications. Under the hood, with Vertex AI Search, what we've done is we have simplified the end-to-end search and discovery process of managing ETL, OCR, chunking, embedding, indexing, storing, input cleaning, schema adjustments, and everything that you would have done if you would have built a RAG application yourself. All of this makes it super easy for you to build RAG power apps using Vertex AI Search as your retrieval engine, right? So this is again one of the options that you can consider when you're grounding your Gen AI application to your own enterprise data. Which brings me to the topic of grounding. So like I said earlier, for a straightforward approach, consider grounding language models to your own text data using Vertex AI Search that we discussed in the earlier slide. Alternatively, you can also explore Vertex AI Vector Search, which is essentially a low latency vector database that we provide, wherein again you can store the vector embeddings that you create. You can store all of those into Vertex AI Vector Search, and you can query them, retrieve the search results in a low latency manner if you want to build your search algorithm yourself. Or if you have data that is stored in OLTP database or a SQL database, right? So you also have options such as AlloyDB and Cloud SQL for storing and querying the vector embeddings within a SQL database. Now, AlloyDB also enables direct integration with Google AI models, right? So right from within AlloyDB itself, you can directly call or use the Google AI models from within the database. Finally, for large analytical databases or data sets or data science requirements that you might have, BigQuery is the other option that you have, which offers native integration with LLMs and supports LangChain integration as well for building a seamless control of information flow within your grounding algorithms, right, or grounding flows. So now that we have all the important decision factors covered, which is the application hosting infrastructure, the model hosting infrastructure, the grounding solutions that we have, the biggest question in your mind might be, how do I get started with all of this, right? So to assist you in this, and yeah, sorry, before I forget, you can even ground with Google search in Vertex AI, right? So if you go to Vertex AI Studio within the GCP console or through an API, you can ask Vertex AI to essentially, you can ask Vertex AI to essentially ground your search results or the search results from the large language model with Google search, right? So this again solves for a problem wherein if the model is trained with a particular dates data set till a particular dates data set, you can, with grounding with Google search, you have access to the latest information which is available through Google search, right? So this is again a very important factor that you should keep in mind. Now, the biggest question that I mentioned earlier, right? So where do I even start, right? So what we've done is we have developed a suite of pre-built Gen AI sample applications which are ready for you to deploy on your Google Cloud project and tailor to your specific use cases, right? So all of this is available in a GitHub repository. To access the repository, you can simply scan the QR code that we have provided here. I'll also paste the URL in the chat box as well. So give me a second. Yeah, so you should have the chatbot, or you should have the GitHub link as well. Now, if I share the GitHub repository that I was mentioning, right? So if you look at this, these are the sample applications that we have, right? So we have a bunch of applications, starter applications that we have created using the different technologies and the methodologies that we discussed in the few slides earlier, right? So we have Python applications, we have Java-based applications, we have an application which uses a RAG kind of an approach to do grounding for the application. We have an image recognition or a text to speech kind of a use case as well. We also have a final application that you see here, sample application, which is using AlloyDB to essentially query the data that is stored in the database. You also have document AI to process unstructured documents or the documents that are available in cloud storage, right? So the idea is that you can essentially deploy these sample applications in your own Google Cloud projects, and then essentially you can fine tune or modify the code, right? So the code is also available to you. So like say for example, if I go to Gemini Streamlit Cloud Run, I can see that there's a Python file. I have the detailed steps that I can use to deploy this application into my Google Cloud project. So I can essentially access the application and look at the various components within the application and understand how the code has been written versus what it shows in the front end, right? So we have a sample front end that has been created as well. And then essentially it will also allow you to be able to explore and easily understand. So say for example from Python, how do you integrate Python to the Gemini endpoints, right? So say for example in this case we can define a function which is calling the model. I also define what my model is going to be. And then I can specify certain parameters such as temperature, what the max output token should be. I can also pass certain safety settings which Google Cloud allows you to provide. And then I essentially call that model and generate the content basis the input prompt that I provide, right? So this is again a sample application that is available that you can run yourselves, understand how do you integrate this with the APIs that we have available in Vertex AI, and then modify this code to build your own applications. Similarly, if I show you one of the applications that I've deployed in my own Google Cloud project. So again, this is something which I've picked up from the same GitHub repository that I shared earlier. So you can see that I have different options in this sample application, right? So I can enter a character name, I can enter various options, I can click on generate my story, which will essentially generate a prompt and trigger that prompt against the Gemini API that I'm calling, and essentially it will give me the response, right? So I can also essentially look at what the resultant prompt was that was sent to the Gemini endpoint and the output from the prompt as well, right? So this is again a very easy way for you to be able to understand how do you integrate the various endpoints or the various APIs using SDKs, right? So you can see that this is what the output is versus this is what the prompt was that was passed to Gemini, right? So going back to the presentation, I hope you have access to the GitHub URL that you can use to essentially access this GitHub repository that I mentioned, or you can scan this QR code and you can get access to the GitHub repository. This is again showing a screenshot of what we have. We already covered this, so I'll skip this. Okay, now coming to another important topic, right? So now we have an understanding as to what are the decision factors that we should keep in mind when you design and develop and deploy an app finally onto Google Cloud. One of the things that we discussed earlier was model tuning, right? So there might be a requirement to tune a large language model for your specific use case. What this essentially means is that you are adapting Gemini or any of the large language models to specific tasks, enhancing the precision and the accuracy of the large language model, the resultant large language model. So essentially what this means is this typically involves providing the model with a training data set containing examples of specific downstream tasks that the model is to perform. So when we consider the different options for tuning a large language model, we will keep our discussion in these 4 buckets, right? So customization goal, how does it work, data requirement, and the supported models. You are aware of the different options as well as the models that are supported for each of these options, right? So you can decide, you can take this learning with you, and then when you develop an application as part of the hackathon, you can essentially understand what would be the best customization method for your use case. The first one and the most simplistic tuning method is prompt designing, right? So wherein you provide a detailed context, you provide a set of instructions and examples to guide the model's understanding and responses. This is supported for all the Google Cloud Foundation models, right? And this is, like I said, this is like a very simple approach and the most straightforward approach that you should use first. The other approach is the RAG-based approach, which we discussed already, which essentially grounds the model's answers into proprietary data. The target is essentially to reduce hallucination in models. Then we have supervised fine-tuning, which essentially teaches the model new skills using hundreds of labeled examples that we provide, demonstrating what the desired output should be from the resultant model. This process essentially creates a new model, combining the newly learned parameters from the test data or the training data with the original parameters of the original model. And it's essentially recommended for tasks like classification, sentiment analysis, entity extraction, summarization, or writing domain-specific queries. Right? Say, for example, um, if you want to generate a interesting tag for an ad campaign, right? Or if you want to essentially um, for an insurance domain, say for example, you want to summarize a policy document, right? So a lot of this is again the kind of terminologies that you use in the output is very much important, right? So for such kind of use cases, supervised tuning is something that you can explore, right? The next option that we have is reinforcement learning from human feedback, or RLHF. What this means is essentially this is used to optimize a language model based on human preferences, aligning it with human intuition and reducing the undesired outcomes from the complex tasks that you want to give it as an input. For example, RLHF can help with an ambiguous task such as how to write a poem about the ocean, right? By offering a human two poems about the ocean and letting that person choose the preferred one, right? So this is where you're telling the model that this is the input, these are the two outputs that you can generate. Out of these two outputs, this is what the preferred output is based on the human preferences that I have for this particular specific use case, right? So this is a very good option when the output of your model is complex and isn't easily achieved with supervised tuning, right? So keep that in mind. Typically, RLHF is recommended for use cases where you have question answering kind of a use case or summarization of a complex content creation. But keep in mind that this isn't supported by code models. Finally, we have model distillation, which is another technique and is a good option if you have a large model that you want to make smaller without degrading its ability to do what you want, right? So we'll look into the distillation in more details as well, but typically the process of distilling a model creates a new smaller trained model that costs less to use, has a lower latency than the original model, and has the same capabilities or near about the same capabilities as a larger model which you use as a teacher model, right? So that is what distillation means, right? Now essentially let's look at supervised. If I go back, you have supervised tuning, reinforcement learning from human feedback, and distillation, which are like the primary three different ways of tuning a large language model. So let's look at all of these three in details. So with when you want to do a supervised fine tuning for a model, a typical workflow would mean that you first prepare your model tuning dataset. You then upload the model tuning dataset to a cloud storage bucket. You can then create a supervised model tuning job, right? So you can use Vertex pipelines to be able to essentially create that tuning job. Once the tuning job is completed, the adapter layers are again frozen or stored, or the stored essentially along with your the frozen foundation model serving that you have. And the final tuned model is also available or stored within Vertex model registry, right? So once it is there within Vertex model registry, you can deploy that to a Vertex endpoint, right? And then you essentially use the endpoint for your inferencing requirements. So once you do this, if you go to Vertex AI Studio, for all those folks who are familiar with the Vertex AI Studio within GCP console, once you go to the Vertex AI Studio, on the right hand side top, there is a drop down wherein you can select a large language model, right? So a tuned model will also be available in the same drop down. So you can go ahead and test your prompts with a fine-tuned model, from the same. You can select the fine-tuned model from the prompt or from the drop down, and then essentially you can test out your prompts with the original model and then with the fine-tuned model, and then you can essentially see what the difference in the output is, right? So this is what a typical process for a foundation model or a supervised fine-tuning for a foundation model is. Again, in this slide, if you look at the link at the bottom, right? So I'll paste this link as well in the chat window, and you can essentially you can navigate to this link to refer to the documentation that you can, wherein you can get more details about the process of the fine tuning a model, right? And again, if you go to the same GitHub repository that I shared earlier, there are notebooks or starter notebooks that we have created, wherein which give you the entire notebook to be able to fine tune a model, right? So you can customize the model. You can just add your own data set to the same fine tune the notebook, and do a fine tuning model, supervised fine tuning for your model. So keep in mind that these are the list of models that support supervised tuning. So the text generation model, text chat model, code generation and code chat, and the text embedding model that we have, right? If you look at it, one of the most important considerations when you prepare the training data set for supervised fine tuning is that you should follow the input, the format of the data set, right? So which is what you see in the example below. The format should be very much similar to what the final format is going to be when you give the final input to the tune model, right? So like in this case, I have an input text and a question which says how many parishes are there in Louisiana. I'm providing a context as well, and then I'm providing an output text, right? So essentially, when my model is tuned with this training data set, when I go ahead and use that fine-tuned model, I should be providing a similar format of the input text as well, right? So it should have a question, it should have a context, and the fine-tuned model will be able to generate a response for you. All right, so just keep this in mind. Now, few important considerations that you should have when you want to decide between fine tuning and or a RAG kind of an approach, right? So if you want to ground the responses based on an external knowledge base, which is stored in a database in a storage somewhere, you should use the RAG based approach, right? If the model adaptation is what is required, right? For example, if you want to control the behavior or the writing style in the response in the final output, or the vocabulary like the earlier insurance example that I gave, that is a very good use case for fine tuning, right? If you want to minimize hallucinations, again, grounding using your own external knowledge base, which is part of the RAG based approach, will help you minimize hallucinations better. If you have a training data available, you can go ahead and do a fine tuning of a model. If you have dynamic data, more dynamic the data, or if you need interpretability of what the final output is, or more explainability of what the final output is, you essentially go for a RAG based approach, right? So these are some important considerations or differences that you should keep in mind, because this is what will help you understand when to go for fine tuning versus when to go for a RAG based approach. Next, we'll look at the reinforcement learning from human feedback. So essentially, like I mentioned earlier in brief, this uses feedback gathered from humans to tune a model, right? So RLHF is recommended when the output of your model is complex and difficult to describe, right? Because of which the human feedback that you provide in the form of choices between different output options is extremely important, right? Because these choices provide better data than labeled prompts that you might use with supervised fine tuning to tune a model that produces output that's difficult to describe, right? Again, I'll show you an example in the next slide. But if the output from your model is difficult to define, then consider tuning your text model by using supervised tuning. On the other hand, if you want to produce, or if you if your output is very complex, right, or if your output of your model is complex, that is when RLHF is recommended, right? Again, in this case, you will have to create a human preference data set, which is basically used to train a reward model, right? Uh, Once you train or once you create that human preference data set, Vertex AI will essentially create and then use the reward model during the RLHF tuning. Right? So essentially, there would be a reward model that would be created, and that is what would be used to create a tuned RLHF model. All of this is created in a private storage bucket in a tenant project, so it's not visible to you. But as soon as the final model is tuned, the reward model is deleted as well. So what you have access to is the final tuned model. Right? Again, if you look at it, the workflow is very much similar. You prepare a human preference data set, you prepare your prompt data set. So there are two different types of data sets that you have. One is a human preference data set and a prompt data set. You upload your data sets to cloud storage bucket, and then you essentially create a tuning job for RLHF that you can then essentially use to um, get the model, right? In this case, also the tuned model would also be visible to you within the console, right? So you can see it from the console itself. So finally, with this, if you look at it, these are the models that are supported, right? So the code models are not supported for RLHF tuning. So you have text bison, chat bison, the T5 FLAN or the FLAN text to text transformer models is what are also supported. If you look at it, right? So if you look at the sample data set for the human preference that we have, the recommendation is that you should have at least 5,000 to 10,000 examples that you have created, right? Because this allows you to be able to get a better training results. So what we have is we have an input text. In this case, create a description for plantation farms. Uh, One of the candidate responses is enjoy some fun in the sun at golf shores. The other candidate response is a tranquil oasis of natural beauty. Right? In this case, the preferred response is choice 0. Right? So we are saying the model that there are two different kind of responses that you can generate basis this input text. But for me, for my use case, the preference is the candidate 0 is what my preference is, right? So this way you are essentially creating kind of a human bias or a human preference bias on the model, and that is what will be used, right? Again, I have the URL for RLHF fine tuning. I'll paste this as well in the chat box, so you can access this link as well. Now, finally, we have distillation step by step, right? So this is again one of the latest techniques that have come from a Google Cloud research paper, right? If you search for distilling step by step in Google, you would be able to, go through, read that Google Cloud research paper, uh, wherein essentially the idea is that you use a large teacher model, is what we call, to train a smaller student model to perform certain tasks better with improved reasoning capabilities, right? So the trained distilled model can do the same things, right, or near about the same things you care about in the larger teacher model at a lower cost and with lower latency, right? So remember the point that I mentioned earlier, that one of the most important factors when you choose a model is also the cost, right? The larger the model, the more parameters the model has, the more costlier it is going to be for you to be able to either host it on an infrastructure, because now it would need, a much larger, infrastructure, much more advanced GPUs. So, or even if you go for a pre-trained foundation model, which is a larger foundation model, it would be costlier, right? It would not be cheaper. So the idea is that when you distill a foundation model, you use a teacher model and a student model. The teacher model is the large model that can do what you want. Right? So you have already tested your prompts with the larger model, and you know that it's able to give you optimum results based on your use case. However, like I said, because of its size, the teacher model might cost more to use and have more latency than a smaller model. The student model is a smaller model than the teacher model. So essentially, as part of the training and distilling process, it uses labeled examples and rationals generated by the teacher model to tune the student model, right? So if you look at the example here, so we are passing a question, we are passing a prompt to the teacher model saying, the cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have, right? Next, what we're asking the teacher model to do is think step by step and give us the rationale behind the response and the prediction as well, right? So it gives you a rationale saying the cafeteria had 23 apples originally, they used 20 to make lunch, so they had 23 minus 20, which is 3. Then they bought 6 more apples, so now they have 3 plus 6, which is 9, right? And then gives you the prediction. So it's giving you a rational or a step-by-step approach to how it came to the response and the prediction as well, right? So essentially, this is what your training data set should look like for distilling step by step. And after distilling completes, you essentially, the distilled model is again deployed to a Vertex AI endpoint, and this will also be available to you or visible to you within Vertex AI Studio, right? So you can again select it from the drop down and test it against a prompt. Now, with distillation, the only thing that you should keep in mind is that the regions, because depending on the models that you can choose, right? So the only teacher model that you can specify today within Vertex AI is text unicorn, and the only student model that you can specify today is text Python, right? So just keep this in mind. The workflow is again very much similar. You prepare a tuning data set similar to what we saw, in the previous slide. You specify the teacher model, the student model, upload the data set, you create a distilling job, right? Again, I have a link here that I will again share in the chat box that you can refer to. Even for this, even for distillation step by step in the GitHub repository that I share, there is a notebook that we have created that you can leverage, right? So keep that in mind as well, and you can go through the notebook in the GitHub repository and you can use it for your own use case, right? So like I was saying earlier, in this case, you can specify when you create a tuning job, you can specify 3 Google Cloud region settings, right? So you can, one region is where the pipeline that tunes your model runs. The other region can be where the model tuning portion of the distillation process runs. And finally, the third region can be where the distilled model is uploaded, right? So you have different options. Again, if you look at the documentation, there are different options that are available to you. So to summarize, you have all these different options to customize a large language model, right? So you can either go for prompt tuning or a prompt engineering, which is the simplest way. You can go for RAG-based approach, which allows you to reduce hallucination basis the enterprise data that you have, or ground the data to an enterprise source of truth. Or if you want to have a tuned adapter or a tuned model created, if your use case permits, you can go for either supervised tuning, reinforcement learning from human feedback, or distillation, right? So again, if you would have noticed, this is in the increasing level of complexity, right? So prompt tuning is the simplest method, whereas distillation would be like the most complex method for you, right? So keep this in mind when you are deciding on if there is a need for customizing a large language model. So to summarize, we covered the entire development process, the end-to-end development process for GenAI applications, right? You start with choosing a model, designing prompts, customize the model if required, evaluate the model basis the prompts that you have and basis the use case that you're trying to develop it for. If required, you deploy that model to an endpoint that you can then integrate within your application, right? And finally, we also saw the starter applications that are available in the GitHub repository, and which is a very good way for you to start, right? So you can access the GitHub repository, go through these starter applications, and hopefully you can integrate this, or you can take the learning from these starter applications when you go ahead and create a solution for basis the use case that you might have picked up as part of the hackathon. You can use that. With that, I'll open for any questions that anyone might have. Plus, also just a reminder, if you have not signed up for the hackathon, there is a link that was available in the chat. So please do sign up for the hackathon as well. So with that, I'll open up for questions if there are any questions. Okay, the first question is, can you suggest any data extraction models from image or documents, it's been difficult for me to find out a precise model and cost effective. Okay, so see, if your use case is specifically for images, right? So if from images you want to extract information, Gemini models is something that you can use, right? Because Gemini is an inherently multimodal model, so it can very easily understand the content or the context within the image and give you what the output is, right? Same thing you can use for documents as well, right? So like I said, both Gemini 1.5 Pro, Gemini 1.5 Flash, they have a very large context window. So you can essentially say, if you have like 100-page PDF, right, which has a lot of images as well, you can just feed in the entire PDF to Gemini, write a prompt saying that extract these details from this particular PDF document. Also look at all the images that are contained within the PDF document and give me a summary of what is the data that is contained in the PDF images, or the images within the PDF, right? Gemini will be able to do that for you, right? So my suggestion will be just try out Gemini first, because if you have large unstructured documents, say PDF files or images, Gemini should work wonders for you. And in fact, in the GitHub repository, there is a notebook which is available for this particular use case as well. What is Vertex AI, and are Vertex AI and Gemini same? Okay, so very good question. Now, I understand a lot of you would be familiar with Gemini, right? Or Bard as it was earlier called. So if you go to gemini.google.com, that is the, I would say, the open source Gemini models that we have. So you have Gemini 1.5 available with Gemini or the gemini.google.com as well. But like I mentioned in my first few slides, it is not an enterprise offering, right? So it is good for, as a developer, if you want to just understand what are the capabilities of the Gemini models, you can go to gemini.google.com, right? So give me a second. Yeah, so if you go to gemini.google.com, right? So essentially that is what the open source Gemini is. What we have done is, when you want to build an application for your enterprise, right? For your company, say for example, right? You would want to have data security in place. You don't want the prompts that you pass to the models for anyone to have access to, right? This is where Vertex AI comes to the picture. Vertex AI is a service within Google Cloud which allows you to be able to train an AI/ML model from scratch end to end. Within the same platform, what we've done is we also have these Vertex AI models, or the Gemini models, right? So just remember two things. If you're just starting to explore Gemini models, you can still go to gemini.google.com, explore, give it a prompt, explore the model and see what is the kind of output that you get. Once you start deciding on building an application for your enterprise, right, security becomes very important. That is when you should go to Vertex AI and use the Gemini endpoints within Vertex AI, right? Because any prompt that you pass to Gemini on Vertex AI, Google doesn't have access to your prompts, right? As soon as the response is generated, the prompt gets deleted from the memory, right? So keep that in mind. Hope that was helpful. Any other questions? Are there any limitations of RLHF? So the biggest limitation for RLHF would be that the data set that you have to create, right? The data set, like I showed earlier, the data set has to be in a format wherein you give it the input and then you give it two candidate responses, right? And then you say that this is what the preferred candidate response is. So it might not be suitable for all the use cases, right? Typically, RLHF is only recommended for a use case wherein you have a very complex set of tasks that you want the model to perform, because creating a data set with different candidate responses itself is very complex, right? So that is, in my understanding or my perspective, the biggest limitation for RLHF. Okay, so the fourth question is, can you please suggest some ways to customize a brand logo into all the images? How can we tune image models? Which base model should we choose? Okay, so now there are a lot of different models which are available which allow you to customize images as well. With Vertex AI, the Imagen model that we have, there is an editing feature as part of the model, right? So what you can do, say for example, is if you have like a brand logo, right? If you want to say expand the background for the brand logo with some graphics, right? Some text or some graphics, say for example, that is something that you can do today with Imagen. If you want to edit, if you want to change the logo into a different logo altogether, you can still uh, try and use Imagen for that. But again, the prompt will have to be very particular, right? And you might not get very good response, frankly, with that, because primarily it is more designed to allow you to edit images from an out painting perspective, in painting perspective, and all those things, right? Again, for tuning Imagen models, we do have some capability for tuning Imagen models as well. I can paste the link here. Essentially, this is very much relevant for use cases wherein you have you can give a few short learning, right? Say for example, if you're a retailer and if you have like product images, and then you want to modify, you want to create new images which have the same product image in those new images, right? So that is where typically tuning an image model would be essential, right? So I can I've pasted the link, and you can access this link to essentially look at. The next question is, wanted to know more about Google AI Studio, how to use it to create models and AI applications. Okay, so Google AI Studio again is an open source offering that we have, which allows you to be able to develop an application around the large language foundation models that Google offers. So what you can do with Google AI Studio is you essentially start writing prompts to begin with. You develop your application, you integrate with the endpoints and everything within Google AI Studio. And then essentially, if you want, once you're ready to port your application from Google AI Studio to Vertex AI, you can even do that, right? So at the click of a button, you can essentially port your code from within Google AI Studio to Vertex AI, right? So it provides you those capabilities as well. So essentially, you can think of Google AI Studio as a starter application which allows you to be able to start writing prompts and interacting with the foundation models, and essentially build your applications using the SDKs that the Vertex AI or the AI SDKs or the foundation model SDKs that we have provided. And then essentially once you're ready, you can port it to Vertex AI. Okay. I see there are no more questions. So thanks everyone for attending the session today. And as a reminder, please do register for the hackathon as well. You see the QR code here. And hope this session was useful, and thanks everyone for joining. Thanks.